Derivative of vector valued functions with respect to scalar. Here we have considered O is the fixed point, it is origin. OP is the vector R. OQ is the position vector R plus delta R. And this distance PQ between 2 points is delta R. Let us consider a vector valued function R as ft. This function R and R plus delta R are position vectors of the points P and Q. This point P and Q. So OP is R. Let us consider ft. OQ is equals to this one, and then PQ equals to, as we know, OQ minus OP. This is PQ. We will obtain this way. Therefore, R plus delta R gives this one, and delta R upon T, delta T gives us F vector function F T plus delta T minus Ft upon T. T is a scalar, it is parameter. Now if Q tending to P, Q and P approaches 0, then a small increment delta T tending to 0. So this one will be dr dt. Derivative of vector function R with respect to T. Similarly, we can obtain d2R, dt2 and higher order derivatives with respect to scalar, because dr dt is itself a vector function of T. So its derivative is d2R dt2, and similarly we will obtain higher derivatives. Now unit tangent vector denoted by these symbols, we can use any one symbol. So unit tangent vector dr dt upon magnitude of dr dt. Unit normal vector perpendicular to tangent denoted by this symbol or this symbol or n cap, t dash upon magnitude of this unit tangent vector, where this derivative of t dash t is not 0, then we will obtain unit normal vector. Now magnitude of vector A, where A is given by xi cap plus yj plus zk. Therefore magnitude of vector will be denoted by square root of x square plus y square plus z square. Also we will obtain unit vector A cap equals to vector A upon magnitude of A. So we will obtain in this way. Here we have class or function of a curve. Define a curve. A curve is locus of a point whose position vector r vector or a vector relative to a fixed origin may be expressed as a function of a single parameter. The curve is locus of a point whose Cartesian coordinate xyz are functions of a single parameter t. If curve is not a plane curve, it is said to be skew, twisted or tortuous. We have functions of class m denoted by Cm. Cm function if f has continuous derivative of mth order at every point of interval I. If f is differentiable and infinitely many number of times, then it is said to be class infinity or C infinity function. The function also known as analytic over interval I if f is single valued and possesses continuous derivatives of all order at every point of given interval I. An analytic function is said to be of class omega or C omega function. And a vector valued function, like in this way, a x I y j and j z k cap defined on an interval is known as of class m if this vector has a continuous derivative of mth order on the given interval I at each point on the given interval I. Here each of the components x, y, z is of class m. A vector valued function is regular if its derivative, like in this way, dr dt of vector valued function with respect to scalar, never vanishes on the given interval I, or its components, derivative of its components like dx dt and etc. never vanishes simultaneously on the given interval I. Also we have derivative of constant because unit vectors I, j, k cap are unit vectors and these are constant vectors. So derivative of I, j, k is 0. So it is the 0 vector. So we can say derivative of constant vector is equal to null vector, zero vector. We have some theorems. Necessary and sufficient condition for a vector A to have constant magnitude, then the product, you can say dot product of these product with respect to derivative and vector dot product equals to zero vector. Similarly, the necessary and this is the theorem, another theorem, necessary and sufficient condition for vector A, or we can say vector ET, to have constant direction is vector cross product derivative of that vector equals to zero vector. So these are some results. This is arc length. Arc length in our given figure, this is the arc, and in figure like in this way, O, and this is S, C. How can we obtain C, P arc length S? So we will use this T0 limit initial point T naught to T square root of x dot square plus y dot square z dot square dt. So Cp is the arc, and we will obtain by using this formula simply. Now we will work on some questions. So these are basics about derivative of vector valued functions with respect to scalar, and we will use some terms and definitions, theorems in our practice questions. So we will see in some questions based on derivative vector valued functions, unit tangent vector, unit normal vector in 3D video. Thank you.